before I forget. And then we're going to start. I will share my screen, and you can check the answers to the homework for today. And then we'll talk about those, and then we'll get back to work.
Can you go over 91?
Definitely. Okay, so hang on, just trying to get everything situated here. All right, we'll come back to this in a minute. So 91 was here. Let f be a polynomial function with values f prime. Always remember what is actually in the table or on the graph at selected values of x given in the table above. Which of the following must be true for -2 to 6 non-inclusive? So the graph is concave up. That means what about f double prime? F double prime has to be what?
Greater than 0.
Greater than 0. Okay. And that means, because remember, like f double prime is the slope of f prime. So if the slope has to be positive, this means that f prime is increasing. So is f prime increasing? No, it goes from 3 to 1 to 4 to 7 to 5. That's not increasing. Okay, it's all over the place. So it can't be that. B, the graph has at least 2 points of inflection. Okay, so what happens at a point of inflection?
The second derivative equals 0?
Yes. So that means that f double prime is equal to 0. And if it's an actual point of inflection, it also means that the sign of f double prime changes, right? It's not enough that f double prime is equal to 0, because you could have that happen in some different ways. You actually have to have the sign change, which means, based on what we talked about for option A, that f double prime changes from increasing to decreasing or decreasing to increasing, right? Because remember, f double prime is the slope of the f prime graph. Okay. So if we look, as we go from -2 to 0, the slope goes this way, right? Because it's going from 3 to 1. The slope goes this way from 0 to 3 because it's increasing from 1 to 4. it keeps increasing here from 4 to 7, but then it decreases again as we go from x equals 5 to x equals 6. So the sign of f double prime is changing here and here. Okay. So that gives me 2 points of inflection. So far, B looks pretty good. Okay, we can keep looking. And you should keep looking, because what if there's a mistake in your logic for part B? Okay, so let's look at option C. If F is increasing, what should F prime look like? It should be positive, right? So F prime should be greater than 0. And not only that, let's see. Well, yeah. And it's not, because the slopes are changing. So let's keep looking. D, F has no critical points. What do we need for critical points?
Wait, but isn't F always like, yeah, the slopes might change, but it just keeps going up.
It does. So let's keep going. Yes, Sarah, you have a valid point. We'll come back to it. Okay. So how about D? F has no critical points. What do you have to have a critical point?
Derivative equal to 0.
Right. So I have to have F prime equals 0. Does it look like F prime is ever equal to 0? No. Well, and actually, Sarah, here's the answer to your question. Okay. And it's this word right here, must. Okay. Which means it has to be true. All right. So the reason that letter C might not be true is that when x is equal to 1, say, f prime of x could be equal to -1. I don't know. All right. And that's the thing. And that's why these, and fortunately, you won't have to answer multiple choice questions, but that's the real sticking icky point of this, okay? So this doesn't necessarily have to be true. It looks like it is, but we don't know every piece of information, okay? And the same thing with D. Yes, it could have critical points, or it could not have critical points. The way it's set up right now, F double prime seems to be above the axis the whole time, which would make me think that there are no critical points. But like I just invented this point here for x equals 1, again, there could be critical points. So I can't say that for absolute true. And the same thing down here with E. I can't say that absolutely F has 2 extrema. It might. I could make it be that way, but there's not that imperative that this must be true based on the evidence that I have. And B must be true based on the evidence that I have. Okay? And so at least you will be spared these kinds of questions this year, because they're kind of tricky. Okay? All right, are we good on number 91 then? Okay, then I will pop you back over here so you can look at the answers to 2014 number 5 if you haven't had a chance to write them down. Oh my goodness. OneNote is taking over the world. Let's try to reload the page. There we go. Okay, sorry about that. So here again are the answers to 2014 number 5. Are there questions on this one?
Yeah, can we go over part D?
D, sure. All right, so D says evaluate my integral from -2 to 3 of f prime of g of x, g prime of x dx. Okay. So you have come to an integral. What's the first thing you do?
Solve by inspection.
See if you can solve it by inspection. Okay. And if this were just the integral of f prime of x dx, you could do it, right? Because it would just be what?
F of x.
Yeah. Plus c, or maybe we would use the limits. All right. So I can't do it by inspection because I have more than that. You should suspect that there's going to be something tricky here. Okay, because they're not giving you an explicit function of x. They're talking about f of x's and g of x's. So what's the next thing that we do? What's the next thing on our list?
Algebra.
Yeah, but I can't really do any algebra. There's not really anything to do. So what's the next thing on my list?
Integration by parts.
Nope, that is not the next thing on my list.
Oh, U substitution.
U substitution. Okay, so you should be suspicious that instead of being f of x, this is f of g of x. There should be some bells going off in your head that this is wacky. So if you try, if you let u be equal to g of x, then du would be g prime of x dx. And that's what I have here. So my integral becomes the integral from -2 to 3 of f prime of u du. And then I can use this. Okay, and so this is going to be f of u evaluated from -2 to 3. Emma, this is extremely unprofessional, but I have to ask, is there a dog on your lap?
Oh, yeah.
Cool, excellent. It's just like I kept seeing, I'm like, is that an animal? Nice,
Yeah.
good for you. Okay, so this is going to give us f of g of x from -2 to 3. And then you have to look up on the table. Okay, so what's g of 3 going to be from the table?
1.
1. Good. And what's g of -2 going to be from the table?
-1.
Very good. Thank you, Nancy. So this is going to be f of 1 minus f of -1. Because I got to substitute in for my x. So that's going to give me f of g of 3, but g of 3 is really 1. And then minus f of g of -2, but g of -2 is really -1. And then you have to go back to the table again. And what's f of 1?
2.
Good. And what's f of -1?
8.
Good. And so that's going to give us -6.
Okay, thank you.
All right, good. Any other questions on this part? I'd like to elaborate for just a minute on part B, because you can't just write mean value theorem. So part B says, explain why there must be a value C for -1 less than C less than 1, such that f double prime of C is equal to 0. So what I did there is I found the average value for f prime. On the interval from -1 to 1. And that happened to be equal to 0 when I did the calculation. And then I can say, because f double prime is a differentiable function, it's also a continuous function, which are the two criteria you have to use the mean value theorem. And then I can say that because the average value is this, there must be a C such that f double prime of C is going to be equal to that average value, which in this case happens to be 0. Okay. All right, we good? Okay. Then the next thing is we've got a couple more problems to work on. So I'd like you to work on 2016 number 1, which has the table. It starts with water is pumped into a tank at a rate of W of T. If we go back here, oh dear. If we go back here, it's the second one right here. Okay, so this is 2016. Okay, but that's the one I would like you to work on for now. And then we'll go over it, and then if we have time, we'll do the other one. Okay, but tomorrow we will start problem type 6. I am going to stop sharing and I am going to pause the recording. All right, I'm going to share my screen again in case some of you are ready to look at the answers. Okay. And then we can talk about some of these.
Can we go over part D?
Sure. Let's see, are there answers to any, to A, B, and C first? Because those are a little more straightforward.
Can we do B really fast?
Yeah. Fast, I don't know, but we can do it. Okay. So first of all, is everybody good on A? Okay. I'm seeing nods from the people that I see. If you need help with A, now is the time to kind of say, I don't know what I'm doing.
I don't know.
Oh, somebody?
I don't know how to do part A.
Okay, so part A, you're supposed to find basically, okay, yep, this is it. So for part A, you're trying to find the slope at 2. 2 comes right in here between 1 and 3. Okay, so what you're really going to do is take the change in R over the change in T. And that's how you're going to estimate R prime. So it'll be 950 minus 1190 over 3 minus 1. Okay? You all right, Nancy? Then? Nancy?
I got
Okay, all right. Then let's go back. You're good, Nancy?
Yes.
Okay. All right, then let's look at part B. So part B says use a left Riemann sum with the 4 subintervals indicated in the table to estimate the total amount of water removed from the tank in 8 hours. Are we good with that part?
That's what I want to go over.
Okay, that's what you want to go over. All right, so I'm going to erase this just so that I can kind of draw what I need to draw. Okay, so my subintervals are going to be from 0 to 1, from 1 to 3, from 3 to 6, and from 6 to 8. Okay. And then left Riemann sum means I take the value on this side when I'm figuring out the area of the rectangle. Because remember, that's the whole thing about what a Riemann sum is. Okay, is that I have some subinterval from 0 to 1, and I want to figure out which side of that subinterval I'm going to use. So for instance, if we even just kind of made this graph, it looks something like this. Okay, and here's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So what I'm going to say is for my first subinterval from 0 to 1, I'm going to make it look like this. I'm going to take the value on the left side, which is this 1340, and that's what I'm going to use for the height of my rectangle. And then from 1 to 3, I'm going to use this. From 3 to 6, I'm going to use this. And from 6 to 8, I'm going to use that. So my answer will be the height of each interval. So for the first one, it'll be 1340 times the width of that interval, which is 1. For the second one, it'll be the height, which again, I'm going to take from the left side here. So that's 1190, but now the width of my interval is 2. The next one is going to be from 3 to 6, but again, I'm going to take the height here for R of 3, so that's going to be 950. And the width of my interval is 3. And then the last one, I'm going to take my height right here, which is going to be 740, and the width of my interval is 2. Okay. And then once you actually draw out the graph, you can see that this is going to be an overestimate, right? Because I'm going to have all this extra little area here that's above my curve. Okay, does that make sense to everybody? And I suppose you could draw the graph. You could also talk in words about how it's an estimate because R of t is decreasing. and I'm using the left edge. Okay, we good? Sarah, you got it? Wherever you are?
Yes, thank you.
Okay, you must be up at the beginning. All right. Okay, so somebody wanted to do part D, right? Okay.
Okay, first, really quickly, like for part C, what did you get when you did the integral of W of t?
I think I got 7,836.
Okay.
Can you go over C? It's pretty
See?
standard just plugging in. I just want to make sure I want to I'm
Sure.
correct. I got wrong.
So for part C, the total is going to be so I'm looking for the total at time t equals 8, right? Because that's the end of my 8 hours. So it's going to be whatever I started with. And we talked about this a couple different times with different problems, is don't forget that there may be an initial value plus W of 8, the amount of water that's pumped in, minus the rate at which the water is removed, and you're supposed to use your estimate for part B for R of 8. Okay? And then W and really for W of 8, so this is going to be T of 0 plus my integral from 0 to 8. It really shouldn't be W of 8. That's not really the right way to write it. Of 2,000 e to the negative t squared over 20 minus R of 8. And this is 50,000. And like I said, I got 7,836.195 minus 8050. Okay. All right, we feeling good? We got it? Okay. So part D now says, is there a time t when the rate at which the water is pumped into the tank is the same as the rate at which the water is removed from the tank? All right, so I looked at this. I'm just going to go to a new slide here. I looked at part D as an intermediate value problem. And I looked at it as if the rate the water was pumped in minus the rate that the water left at the beginning. And I compared that to what it is at the end. Okay. And those are values that you can calculate. Okay. And it turns out that this is greater than 0 and this is less than 0. Okay. And if the rate at which the water is pumped into the tank is the same as the rate at which the water is pumped out of the tank, then that means that some W of t minus some R of t is equal to 0, right? If they're the same value. So I am told that my function r of t is differentiable, which implies that it is also continuous. If I just look at my function for w of t, that is also differentiable and continuous. Okay, it has nothing that's ever going to give me something funky like a 0 in the denominator. So if those two things are true, that means that by the intermediate value theorem, the difference between these functions, okay, because if I take two differentiable continuous functions, if I add or subtract them, I still have to have a differentiable continuous function. That means that this, my new thing here, w of t minus r of t, takes on all values on the interval from 0 to 8. And because some of the values of my function are greater than 0 and some of them are less than 0, this function must cross the x-axis, which means that at some point it needs to be equal to 0. Okay. So this implies that it must cross the x-axis, which implies that at some point w of t minus r of t must be equal to 0. Okay. All right, we good? Okay, so what I would like you to do then is to do the last problem, which is 2007, number 3. So that is a problem from class here, 2007, number 3. So I would like you to spend the rest of class working on this. The last minute or two of class, I will put up the answer so that you can check your answers and see if you can figure out what the answers are, or figure out where you went wrong. And then the homework, which is posted on the portal, is to do the last homework problem, okay? Which is similar to the problem we already did with a table and some related rates, okay? And then tomorrow, like I said, we'll go over those and then we will start type 6 problems. So I'm going to stop sharing and pause recording. I'm going to share my screen again just so you can see what the answers are here. That's the way I want it to be.